This is the video for Study Guide Unit 5A. On problem 1, it says in triangle DEF, identify the following: the vertices, the angles, and the sides. The easiest way to do this is actually to sketch the triangle and label it. Remember, when you're sketching and labeling the triangle, you start with one vertice and then you go around clockwise, labeling the other one. So the vertices, think of them as the corners, are point D, point E, and point F. The angles are angle D, angle E, and angle F. And the sides are line segment DE, line segment EF, and line segment FD. Problem 2. The angles of a triangle measure 42 degrees, 62 degrees, and 86 degrees. Classify the triangle by its angles. All of these angles are less than 90, so this is an acute triangle. An acute triangle is a triangle where all the angles are less than 90 degrees. The sides of a triangle measure 7, 8, and 8. Classify the triangle by its sides. Since there are two sides that are the same length, this is an isosceles triangle, because that is a triangle that has two congruent sides. For questions 4 through 6, draw the triangle and include the appropriate markings. This wants you to draw an obtuse isosceles, where we said isosceles is two sides that are the same, and obtuse means that the angle is greater than 90 degrees. So the correct markings would be to show that these two sides are congruent. An acute scaling triangle. Acute means all the angles are less than 180, and scaling means that all of the sides are different lengths. So this would be an example of an acute scaling triangle. And an equilateral, equiangular triangle is a triangle where all sides are congruent and all angles are congruent. And you would have to have these markings to show that.
Here in number 7, we are asked to find the value of x and the measure of each of the angles in the triangle below. So if we think, we know that the measure of all angles in a triangle must add up to 180 degrees. And so since we know we have expressions for each of these angles, and that means we can take each of those expressions and add them together and set them equal to 180 degrees. So in this case, we have x plus 3 plus x minus 5 plus 2x minus 6, and then we can set that equal to 180. So if we go ahead and combine like terms, we have x plus 2x, which gives us 4x. And if we take 3 minus 5, that will give us negative 2. And negative 2 minus 6 gives us negative 8. And so now we have this 4x minus 8 equal to 180. We go ahead and add 8 to both sides. We get 4x equal to 188. And if we divide both sides by 4, we get x here to be 47. Okay? So now that we found x, we can use that to find all our different angle measures by just plugging in 47 for each value of x. So for example, if I take 47 plus 3, I get 50 degrees for that top angle. If I take 47 minus 5, I get 42 degrees. And then if I take 2 times 47 minus 6, I get the last measure of angle, which would be 88. I could also check this work by just adding the 50 plus 42 and add 88 to make sure it equals 180, which it does. Let's go on to number 8 here. So in this case, we are given that we have an equilateral triangle PQR. So equilateral here means that all our sides are going to be the same. So I'm going to mark them all congruent and label it PQR. But since this is an equilateral triangle, We also learned that that means that our triangle is also going to be equiangular. So that means all our angles here are also going to be congruent. We're also told that the measure of angle Q is 4y minus 20, and also the length of side PR is 2x plus 2. So let's go ahead and label that in our picture. And it also tells us that the perimeter of the triangle PQR is 42. And then we're asked to find the values of x and y. We'll note here that x is a side length and y is part of an angle. I'm going to start here with our finding y since this is an angle. So we need to be able to find the measure of each of those angles so we have a value set equal to. Well, since all angles in a triangle must equal to 180 and each of our angles are the same, I can go ahead and take 180 divided by 3 to get 60 because each of our angles in an equilateral, which also means equiangular triangle, must be 60 degrees. So I get 4y minus 20 equal to 60. So if I go ahead and add the 20 over, I get 80, and then I divide by 4, I get 20. So this means here my value for y is going to be 20. Now our x here is going to be part of a side, so I had to use that piece of information given to us. The perimeter of triangle PQR is 42. Remember, perimeter is all the sides added together. Well, since all the sides are the same, I can kind of do what I did with my angles, but I can take that perimeter and divide by 3, which gives us 14. And so that means here, since all the sides are the same, all the sides here are going to be 14. So I can take my expression, 2x plus 2, and set it equal to 14, and then solve. So if I subtract the 2, I get 12, and then if I divide by 2, I get x equal to 6.
They are asking what types of triangles are regular. Well, remember, regular means all the sides are equal and all the angles are equal. So it would be an equilateral, equiangular triangle. Number 10, an isosceles triangle has a base of 14, a leg of 2x minus 8, and another leg of 20. What is the value of x? The thing I want you to do again is draw this. And they said our base was 14, and it is an isosceles, so I know these two sides are congruent, and one of those is 2x minus 8, and the other is 20. So I know that 2x minus 8 must equal 20. And then I'm going to solve using algebra, and I'm going to get that x equals 14. On problem 11, find the value of x, y, and z, and these are all angles. We'll notice that across from angle that is z is 136 degrees. Those are vertical angles, and therefore congruent, because all vertical angles are congruent. So angle z equals 136. Well, would you agree that angle z and angle x form a linear pair? And remember that linear pairs are supplementary, so they equal 180. So I know that z plus x, not z, plus x equals 180, and I know that z is 136. So 136 plus x equals 180. So therefore x has to equal 44 degrees. All right, and so the only thing I have left is y. Well, again, I know, because these are a linear pair, that this angle right here, this unnamed angle, is 56. I know that x is 44, so since there's 180 degrees in every triangle, if I subtract 44 and 56, I am going to get that angle Y equals 80 degrees. And on a test, I would want you to write the measure of angle Z equals 136. And the measure of angle X equals 44 degrees. In problem 12, they want us to find the value of X in the diagram. Well, again, vertical angles are congruent. So I know that this angle is X plus 7. And if I add all three of these angles, it must equal 180. So that's exactly what I'm going to do, is set that equation up and then solve it. And I get that X equals 13. In problem 12, we learned that an exterior angle, which is what 120 is, equals the sum of the interior angles. So I can say 40 plus 2x, or the sum of the two of the two angles that don't touch the exterior angle, equals 120. There we go. So I'm going to set that up, and I'm going to get that 2x equals 80, and therefore x equals 40. Okay, on problem 14, in the diagram below, the two triangles are congruent. So I am telling you that they are congruent, and you are going to fill in the blanks. So we kind of have to rotate our second triangle so that we can see corresponding angles. And let's do that first. So X corresponds to angle C, and angle Z corresponds to angle A. Now you're not going to just put the letters, you're going to put angle with it. And angle Y corresponds to angle B. Therefore, side YZ corresponds to side BA, and side XZ corresponds to side CA, and side XY corresponds to side CE. Now that I know that, I can write a congruent statement, which is what this is. And this says triangle XYZ, and I must mention the vertices in the same order. So what corresponds with X is C, it goes first. What corresponds to Y is B, that goes next, and what corresponds to Z is A. So that is the congruent statement.
In number 15 here, we're given that triangle DYM is congruent to triangle FGR. We're also given that the measure of angle G is 75 degrees, and then the measure of angle M is 40 degrees. So I'm going to start off here by drawing our two triangles. We're going to label the first one here as that DYM. But then since these are going to be corresponding triangles, we need to make sure that we label these in the exact same place. So that means that D is in the same place as F, Y is in the same place as G, and M is in the same place as R. If I go ahead and add my two angles here, we're given that the measure of angle G here is 75. So I'm going to label that. And then the measure of angle M here is 40 degrees. But since these have corresponding angles, we know G corresponds with Y, so it must also be 75 degrees. And angle R corresponds with angle M, so it must also be 40 degrees, because they are congruent, since they're corresponding, since the triangles are congruent. So the next thing our first thing we're supposed to do here is find the measure of angle D. Well, if we look at triangle DYM, we notice that we have two of the angles, which means that we can find the third by adding the other two together and subtracting from 180. So I'm going to take 180 minus 75, And then also subtract 40, and this gives me 65 degrees, which means the measure of angle D is going to be 65 degrees. But that also means that angle F will also be 65 degrees. But since we're only asked for angle D's measure, we'll go ahead and get that. The next part here says, what is the value of x, is the measure of angle R, is equal to the expression 2x minus 6 degrees. Well, we already labeled, since we knew that the measure of angle M was 40, R also corresponds with M, and so it is also 40. So we can take that 2x minus 6 and set that equal to 40. And then we just need to solve this equation. We can start by adding over the 6 to both sides, which will give us 2x equal to 46. And then we can divide both sides here by 2, which gives us x equal to 23. And so that will be our value of x. The last one here says, which side is the longest side in triangle DYM? Well, if we think back, we talked about before how that the longest side is always opposite the largest angle. Same thing that the smallest side is opposite the shortest, or shortest side is across from the shortest angle. Well, if I look at my triangle DYM, we notice that the largest angle here is angle Y at 75 degrees. And so that means that the side across from it, DM, will be the longest side. And so since angle Y is the largest angle, it must be across from the longest side, and that will be DM.
On problem 16, it says place the sides in order from smallest to largest. If angle A is 67 degrees, so I'm going to label this as I'm talking, angle B is 59 degrees. Well, I'm going to have to figure out how big angle C is by subtracting both of those from 180, and I get that angle C is 54 degrees. Now, remember, the longest side is always opposite the biggest angle. So, my biggest angle in this is here, so side CB is going to be my longest side. Then my next largest side would be opposite angle B, which is going to be side AC. And, oh, sorry, dropped my pen. My last side, obviously, is side BA. So longest and my shortest. All right, in number 17, they give us side lengths, and they want us to put in order, or place the angles in order. All right, so let's label. They're telling us that side AB is 8, side AC is 7, and side BC is 9. Now remember, opposite the largest angle is the longest side. So I'm going to find my longest side, which is 9, and that is opposite angle A. So I'm going to say angle A is my longest, or my largest angle. And then my next largest side is 8, so opposite that is angle C. And then my shortest side would be opposite, or my, smallest angle would be opposite my shortest side. So that's going to be angle B, and that is going to be my shortest side. On problem 18, you are to determine if the 3 side lengths given would create a triangle. Now remember that any triangle, 2 sides added together must be larger than the 3rd side. So how you do this is you find your 2 smallest sides and you add them together. And is that greater than 8, or the 3rd side? And in this case, indeed it is. 11 is greater than 8. This could form a triangle. On the next one, they're all 7. Well, this would be an isosceles triangle, but if I was trying to prove if they could create a triangle, I would say, does 7 plus 7, is that greater than 7? Yes, it is, and therefore this also could be a triangle. Now let's take a look at this third one. 3 plus 4, is that greater than 7? No, it is equal to 7, but it's not greater than 7, so this is no, could not form a triangle. Now let's take a look at these two. 7 plus 8, is that greater than 16? Well, 7 plus 8 is 15, so no. This also could not form a triangle because 15 is not greater than 16. All right, in the diagram, segment DE is the mid-segment of triangle ABC. So this segment right here is a mid-segment. Remember, a mid-segment is a segment that cuts the two sides in the middle, at the midpoint. Sorry. Segment FG is the mid-segment of the smaller triangle ADE. So they want you to find the length of segment FG. Well, let's first find the length of segment DE. We know, so let's just ignore completely F and G. And let's just look at our big triangle and find DE. We know that a mid-segment is exactly 1/2 the length of the third side that it does not touch. So DE has to be 1/2 of BC. So the length of DE is 26. All right, so now that we know that that is 26, let's look at our small triangle right here, and FG being the mid-segment of that. Now, since it's the mid-segment of this smaller triangle, I know that FG must be 1/2 of the third side, which is DE, and we know that DE is 26, so I know the length of FG must be 13. Okay, and the last problem that we have is, if segment DE is the mid-segment of triangle ABC, find the value of X in the diagram. Okay, well, we said that a mid-segment is exactly 1/2 of the third side, so that makes the third side twice DE. So I'm just going to say 2 times 15, and the length of BC equals 30.